Let's imagine that we have a guy headed for a taco truck. $3 for each taco and $5 for each burrito. The question we might ask is, if he's going to spend $45 exactly, how many tacos and burritos did he buy? And it should be pretty obvious right off the bat that there's a lot of different options. In fact, here's a list of the options that one of my classes came up with. They said, well, he could buy 0 tacos and 9 burritos if he really likes burritos. And he could also buy 15 tacos and 0 burritos if he really likes tacos. And this goes to show that those 2 points, those 2 options, those 2 pairs are really easy ones to find. It's much harder for us to figure out, 5 tacos and 6 burritos, but it's certainly not impossible. So there's 2 variables in this kind of a situation. Variables are quantities that we might change throughout a situation, or maybe some values that we don't necessarily know. And in this case, there are 2 of them, tacos and burritos. So let's make a graph of this information. First, if we put the tacos on the x-axis, which would be our independent variable, and the y-axis would be burritos, that would be what's called our dependent variable, because the number of burritos depends on the tacos, although in this case there's not a very clear one that depends on the other. Most situations do have a very clear dependent variable. So we could go ahead and make a quick graph of this information to represent all of the possible combinations. We'll start with the point 0.9, and then we'll go out to the point 15.0. Now this is just a sketch, so it's not going to be, a perfect scale, exactly same size. We're just trying to communicate an overall picture of this. And once I have 2 points, that's really all I need in order to make a line. And so we'll go ahead then and make a line using our line tool. And this, if I do this more accurately in some sort of graphing software or something, you would notice that it actually ends up going through several points. One of those points that would be on the graph grid would be 5 tacos and 6 burritos. And then another point on the graph would be here at 10 tacos and 3 burritos. And technically there's a bunch of other decimal points that would be in between. But this is a quick way to model this. So what is an equation that might model this situation? Well, let's think about it. How did you figure out the number of tacos that you bought? We knew that tacos were $3 each. And so we might have written a simple equation that looks like this, but more likely in our heads. So $3 times however many tacos we buy, that would be our taco cost. And if we wanted to calculate our burrito cost, well, that would be $5 times the number of burritos that we buy. That's our burrito cost. And if we add those 2 costs together, we come up with a total of $45. So if we define our variables, remember we put tacos on the x-axis, we'll call the number of tacos x, and we'll call the number of burritos y. Then we can write a really simple equation. Take the number of tacos and multiply by 3. Take the number of burritos and multiply that by 5. That's going to be how much money we spend on burritos and tacos. Add those 2 amounts together, and you get 45. So what that means is that in the table, you could put in 0 for x and 9 for y. You could put in 15 for x and 0 for y. You could put in 10 for x and 3 for y. And all of those would give you a total of $45. That is an equation in what we call standard form. So this type of equation where x and y are on the same side, that's called standard form. And when I want to make a graph of standard form, it's really easy. I just need 2 points. The one on the y-axis, called the y-intercept, and the one on the x-axis, called the x-intercept. And I found those by putting in x equals 0 and y equals 0. Let's take a look at this situation. Some swimming pool that has a certain amount of water in it, and we're going to go ahead and drain it. What are the 2 variables in this situation? So variables are quantities that can change or we don't necessarily know the value of, and one of them usually determines the other one. So the best way to think about this is the phrase changing blank affects blank. And in this case, it's pretty clear that changing the amount of hours that we are draining this tank will affect the number of gallons that is still in the tank. And so those would become what we call our independent and dependent variables. The hours would be our independent variable, because it's the controlling one, and the one that it affects would be our dependent variable. And in general, we're going to call the independent variable x and the dependent variable y. So let's make a table to try to analyze this relationship, write an equation, and make a graph. So first of all, we will go ahead and pick some number of hours. So let's go for, like, say, I don't know, 0 hours. That should be pretty easy. So if this tank has been drained for 0 hours and the plug was just pulled, we would have 20,000 gallons. And if we have gone for 1 hour, then we would basically be doing 20,000 minus 1,500, which is going to give us 18,500 gallons. And then at 2 hours, we would be taking away another 1,500, so our calculation would be something like 20,000 minus 1,500 twice. And that's going to be, in this case, 17,000. And then 3 hours, to get that, I don't actually care so much what the number is, although it will help us, but I'm going to subtract 1,500 3 times. So if I look at that, where the 3 times is coming from is minus 1,500 once, minus 1,500 twice, minus 1,500 3 times, which ultimately is going to put us at 15,500 gallons. So we've got a few points, and now we can begin to make a graph. So let's go ahead and create ourselves a graph with our independent variable on the x-axis and our dependent variable on the y-axis. Now that we have that, we can begin to plot some points. So we started with 0 and 20,000. And notice this is a sketch. So I don't need to do a detailed scale. This is just a rough picture of what's going on. So at 0 hours, we had 20,000. At 1 hour, we had dropped just a little bit. So that was 18,500. Then at 2 hours, we had 17,000. And basically, if we look at this kind of carefully, we notice that the slope begins to emerge. That we are basically going to be dropping 1,500, as we gain 1 hour. And we're just going to repeat the same exact calculation over and over and over again until eventually we run out of water. So here we could draw a line using our line tool. Now I didn't make my graph big enough or deal with my slope well enough so that that line would eventually hit the x-axis, which would be the point at which the tank is empty. But let's go ahead and make an equation that would model this. And if we look carefully, we basically had the same calculations over and over and over again. The only thing that was changing was this value right here. And technically we didn't have anything written right here, but if we think about that for just a minute, we subtracted 1,500 one time. So therefore, if I said, hey, you know, our tank has been open for, let's say, n number of hours, then we could get our calculation by doing 20,000 minus 1,500 times n. And if we change the n to an x, so any number of hours, whether it be 12 hours or 15 hours or 27 hours, we are going to take that number, multiply by 1,500, and subtract it from 20,000. And therefore that is an equation that we could use to model this situation. It's a decreasing relationship, and it's decreasing because of the fact that we're subtracting. This 1,500, that is our rate, which is 1,500 gallons every 1 hour. And we saw that in our slope, which is a rate of change. And the 20,000 over there on the side, that is simply our initial, which essentially is the y-intercept. And so this is a form of an equation called slope-intercept. And it tells you exactly what the name implies. It tells you the rate of change, and it tells you the initial value. But we get it often by creating a series of calculations and noticing what's changing each time. So to summarize, there are two types of linear equations that are most prominently featured in the world. Those are slope-intercept and standard form. Slope-intercept is always going to tell you some initial value and tell you how much we're adding or subtracting each time. And standard form is a little different in that it's going to have something to do with maybe a cost or a number of objects, where we end up with a single solid total, kind of like the tacos and burritos example. Notice that the difference between these two forms is that slope-intercept has it as y equals, where standard form has both of the variables together on one side because the situation more naturally lends itself to that.